Hello everyone. So in yesterday's class, we have learned first application or first use of dimension analysis. Now today that is second use. So therefore I'm writing heading that as a uses of dimension analysis only. Uses of dimensional analysis. So yesterday we have learned first one. So now let's move further and let's see another use. So this is second use, that is to derive the equation to derive the equations showing the relation between different physical quantities. Different physical. So this application is very important. Keep it in mind, either for MSET or JEE, you are getting question compulsory on this model. So please keep it in mind. MSET or JEE. So try to understand. Carefully listen. Okay. So see what type of question they are asking on this. So let's see one example. I will solve 2-3 examples and then I will give some problems. You can do it yourself. Okay. Now, how they are asking question C, if mass m comma velocity v and radius r are chosen as fundamental units or chosen as a fundamental quantities. Fundamental quantities, actually they are not. Velocity is not fundamental quantity, but we are choosing like that. Then find formula for force. Formula for force or centripetal force, we can say. Formula for centripetal force. Now we don't know formula for centripetal force. We have to assume like that. Okay, what is the condition? We don't know the formula for centripetal force. Now first we will assume the relation that is F is directly proportional to m power A, this is m, phi power B and R power C. We don't know what is the relation between these all. That's why we have assumed like this. Next, now what I'm doing, I'm adding one proportionality constant. So F is equal to K into m power A, velocity power B and radius power C. Okay, now let's find out the dimension. F is what here? First, when you are doing this, first you find out the dimensions. F is what? Force. As F is force, dimensions of force are what? 1 in mass, 1 in length, minus 2 in time. Okay, force dimensions we know. Next is what? K is constant, so no need. Then next is M. M is what? Mass. So for this, what is the dimensions? 1 in mass, 0 in length, 0 in time. Okay, right. Next is what? Phi. Phi is what? Velocity. Phi is velocity. So what is the dimensions of velocity? 0 in mass, 1 in length, minus 1 in time. Enough. Next, R is what? R is radius. Radius is nothing but what? Length. Yes. So therefore here also M0, L1, T0. Okay, we got all dimensions. Now let's substitute here. At the place of F, dimensions of F. So here I am substituting M power 1, L power 1, T power minus 2. Okay, substituted is equal to, this is K. K is constant, substitute as it is. Next, this is M dimensions now. What are the M dimensions? Here it is. So shall I write only M? M power 1. Okay. And whole power, this is A. Keep it in mind. Next, phi dimensions are what? L T power minus 1. Okay. Whole power B. And next is what here? L and whole power C. Check it. Okay. Now next step. See here. K into, this is M power 1 whole power A means what? M power A. Next, L power B, T power minus B. Just what you can say, this power we have kept inside. And this is L power C. And this side what you are getting? M power 1, L power 1, T power minus 2. Okay. Understood? Okay. So let's move ahead. Now, what we got? This side we got M1, L1, T power minus 2. This is equal to, now this K I am removing. Why? Because it is just constant. So we will keep as it is in the last expression after calculating A, B and C values. So what you got here? M power A and this L power, this B and this C. So L power B plus C. So can I write like this now? M power A, L power B plus C and T power minus B. Now equate the powers. Equating powers, what we are getting? A is equal to 1, B plus C is equal to 1, and minus B is equal to minus 2. So we got A is equal to 1 and this B is equal to 2. So if this is 2, I have substituted here. 2 plus C is equal to 1. So C is equal to how much today? Minus 1. So what we got now? A, B and C values. We got like this. A is equal to 1, C is equal to minus 1 and B is equal to 2. Now what is our relation assumed? F is equal to K into M power A, V power B, R power C. Substitute the values. So what you are getting? F is equal to K into M power A value is 1, so therefore M. V power B means V power 2. R power C means R power minus 1. So what you are getting formula F is equal to K into M V square by R. Understand? Like this you have to find the relation. As K is 1, then F is equal to M V square. And already I told you in dimension analysis, K value should be found experimentally. Dimensionally we cannot find. In the dimension analysis, what we can say? Limitations I already told you. So don't bother about this case. So F is equal to M square by R and into K, whatever it is, not an issue. Understood how to do? It is very, very easy. Okay, one more problem. Let's solve one more problem. If C is velocity of light, if C is velocity of light, H is Planck's constant, H is Planck's constant, and G is gravitational constant. G is what? Gravitational constant. Are taken as a fundamental quantities. The dimensional formula of mass is the dimensional formula of mass is. This is what they have given question. Now let's see how to solve this. Okay, how to solve this. Now what he is asking, dimensional formula of mass in terms of what C, H and G. Yes or not? In terms of C, H and G. So let's start solving this according to our own way. That is, M is diagonal proportional to, let us suppose, C power A, H power B and G power C. So therefore M is equal to K into C power A, H power B and G power C. This is what, let us suppose, assume the relation. Now first to find out the dimensions of given physical quantities. So M is what here? M is mass. Okay. So dimensions of mass is what? Just I am writing m. Okay. Next is what? C. C is what? Velocity. C is velocity. So velocity we know what is dimension of velocity? L t power minus 1. Next h. H is what? Planck's constant. H is what? Planck's constant. So what is the dimensions of Planck's constant? How to find, sir? We don't know this. I will tell you. We have one relation E is equal to H into nu. Nu is what? Frequency. So E is energy. Energy dimensions you know m L square t power minus 2 is equal to H into this frequency is reciprocal of time. So this time went here, this side. So m L square t power minus 2 into this t is equal to H. So this plus 1 and this minus 2 will get cancelled. This is minus 1 and hence you are getting H is equal to m L square t power minus 1. Yes or not? So what is the dimensions? M L square t power minus 1. If you have practice table, then it is very easy for you. If you don't know, at least note down now somewhere at the corner this part. Okay, Planck's constant you know. Okay, next. Now gravitational constant is G. G is what they have given, gravitational constant. Already we have learned this in the class also. We have solved this gravitational constant dimensions from the Newton's law of gravitation. So directly I am writing now minus 1 3 minus 2 m power minus 1 L power 3 t power minus 2. This is what gravitational constant dimensions are. Now let's substitute in this. So what we are getting? M is M only is equal to K. C means L t power minus 1 and its power is A. H value or dimensions we can say. What is this? M L square t power minus 1 whole power B and G value is what? Or G dimensions are what? M power minus 1 L power 3 t power minus 2 whole power C. Now let's collect the terms K into this is L power A t power minus A. Next here it is what? M power A L power no M power B है ना M power B. Okay, because this is B power. So M power B L power 2B t power minus B. Next here M power minus C L power 3C, check it, t power minus 2C. Yes or not? Check once. This step is very, very important. Yes, right? Now collect the terms. This is K. And first we will connect this LL terms, you can see. And then means first M I will collect in sequence M and then last we will connect this T wala part. है ना? Can you see this? This T. So let's collect first M terms. So m power what is there? B and this. So m power B minus C. L power minus A plus 2B, and here it is plus 3C, है ना? Check करो. And next one is T power minus A minus B minus 2C. And this side what you are having there? M power 1, L power 0, T power 0. Yes or not? This is M. I can write like this also, no? M power 1, L power 0, T power 0. Okay. So let's compare the powers or equating powers. What we are getting? B minus C is equal to 1. First equation. B minus C is equal to 1. Call this equation number 1. Next equation is what? Minus A plus 2B plus 3C. Minus A plus 2B plus 3C is equal to 0. Call this equation number 2. Okay. Next, minus A minus B minus 2C. Minus A minus B minus 2C is equal to also 0. Minus A minus B minus 2C is equal to 0. You can see TT, MM and LL. This is your equation number 3. Now solve these equations. Same like your, what you can say, mathematics equations you are having now. You can solve this and you will get something like this. A values A is equal to 1 by 2. Next is B is equal to also 1 by 2, and C is equal to minus 1 by 2. Okay, A is equal to 1 by 2, B is equal to 1 by 2, C is equal to minus 1 by 2 after solving this. So therefore, what is the relation then? M is equal to K into C power. C means velocity of light. Okay, and here C is different. C power is what? 1 by 2. Next, H power 1 by 2, and G power minus 1 by 2. So if we want to rewrite this, we can write like this: K root CH, है ना? Root CH divided by G. This is what the formula for mass if we have chosen this as a fundamental physical quantity, that is C as a velocity of light, H as a Planck's constant, and G as a gravitational constant. Okay. Clear? Solve this. Understood how to solve this? All clear? Note down fast. Okay, finished. So check it once, how to solve. Understand how to solve this. Okay, so I'm sending you some problems. You just solve that. I will send 2 to 3 problems, just solve that on this model. Very important. Okay, so let's stop here for today.